This is a problem from chapter 7. This is exercise number 1. Here we have a random variable, a normal distribution with a mean of 60 and a standard deviation of 9. Now they want us to form a standard deviation with 25 samples, an x bar standard deviation, so that's using the central limit theorem. And then they also are interested in having us compute the sum of x as another random variable. And then, so they asked us these questions. Okay, the first question, sketch the distribution for x and x bar. So this is a comparison between x and x bar, and for your random variable x, we have a mean of 60 and a standard deviation of 9, and so by this notation we see that. Now if we're going to take a look at the random variable for x bar, our mean changes to mu sub x. That's just a notation, and it happens so, or it's mu sub x bar, it happens so that the mu sub x bar is the same as mu, so in this case it would be 60. But our standard deviation is the original standard deviation divided by square root of n. So in this case, square root of n is 25. So 9 divided by square root of 25, which is 5. So that, I mean, if we just punch it in our calculator, that is a standard deviation that's less than 9, clearly. So on the same graph, let's see if we can do this on the same graph. Our x standard deviation, say, would look like this, with a mean of 60. And this is where it changes inflection from being concave up to concave down, is the place where your standard deviation is. So 69, and 60 minus 9 is 51. So this is where your standard deviation happens. Now with our x bar, let's see if we can use a different color for that. For x bar, we have still a mean of 60, but our standard deviation is shrunk to about a 1.8, so it's right here. So 61.8 is where your inflection is going to be. So in other words, it's going to be flattened out, and right around here is where you will get your inflection. So in general, it's going to be a skinnier graph. It's going to peak out a little bit higher than your original graph, but it's still it's gonna look basically it's gonna look skinnier than your x distribution. So that's part A. Part B, it's taking a look at the random variable and describe its distribution. So it's still going to be based on a normal distribution. Your mean is still going to be the same as the original mean, and your standard deviation is a standard deviation divided by the square root of n, square root of 25. We'll write it. So we can rewrite that as the normal distribution of 60 and a 1.8. By the way, these formulas can be found at the end of the section where you have the formulas. You get the mean and the standard deviation for x bar. Now here they're looking for the probability that the random variable, using the central limit theorem, the random variable of the means is less than 60. So that is going to require us to use the normal CDF. And that's using this blue graph, by the way, the X-bar graph. So normal CDF, a low of -1 e to the 99, that's negative infinity. The high of 60, the mean of 60, and the standard deviation of our new standard deviation 9/5. Now, looking at this setup, and being that this is 60, which is the same thing as the mean, you're essentially looking for the area under the curve that's less than 60. Well, that is really just, in this case, is 1/2. We could have put that in our calculator, but we won't waste our time because this high is the same thing as the mean, and so it's just going to be exactly half. The next is find a 30th percentile. For this, if we want to accompany it with a drawing, the 30th percentile would be somewhere over here where this is 30%, and it's going to be set up like this. It's probability that your X bar, this is for the mean, is less than some number, and this is supposed to be equal to 30% or 0.3. So we need to figure out what this number is. This number down here would be that same number as that goes over here. So let's go to our second function and distributions. This is going to require us to use an inverse norm. So the inverse norm function requires an area to the left. Area to the left is 30%, and then our mean and our standard deviation. So let's put all that information into our calculator. We have a 0.3 and 60 and a 1.8. So if we do that calculation, we see that it's 59.05, so let's just call that an even 59. And so that's going to be the value you're looking for. The 30th percentile is 59. I have a couple more questions here, going from 56 to 62. That looks like it's between the means over here. That's pretty close to 1 standard deviation away from the mean, and we know that that's about 68%, but not exactly. So let's do the calculation. This is going to be a normal CDF of the low of 56 and the high of 62. That's probably a little bit less than 1 standard deviation away from the mean on the left side. Anyway, so let's do the calculation. It's a mean of 60 and the standard deviation of 1.8. Let's see how that looks like in our calculator. Second function, bars for distribution, normal CDF, and then we'll punch in the numbers, 56, 62, 60, and 1.8. And so it's 85%. So the probability is 0.8536. Probability between 18 and 58. And so we didn't draw a graph for part E. We could do a quick little sketch over here. Our normal distribution are 60, 56, and 62. Whoops. 56, 62, and so we're shading in this area over here. It's tough to see that graph. So for this one, same idea. We just change these numbers 18 to 58, but the mean and standard deviation stays the same. So let's draw a graph for this. A little bit bigger here this time. This is 60. That's our mean. 18 to 58 would be over here. So this is 18, this is 58, and we're looking for this area, which should be less than 1/2. So let's punch that in. I'm going to recall my previous entry, so I'll press second function in entry, and then I'll just arrow back to change the low and the high. Once the low was 56, but now our low is going to be 18. And then our high is going to change from 62 to 58. So 18 to 58. Everything else is the same, so I'm going to go ahead and press enter. And it's going to give me a 13%. So that's a 0.1332. Let's call it a 3 because of the rounding. Okay, the next question is going to be dealing with the sum distribution instead of the mean distribution, and for that we have to try to remember what the mean for the sums would be and the standard deviation for the sums, and so they're all based on that variable, and so the x, the mu is going to change to this. So we have our n is 25, and our mu, original mu was 60, and our original standard deviation was 9. So notice there's no sub x over here to deal with the mean. Okay, now based on the mean sums, don't really recall a symbol for this. So the mean for our sum distribution, I'll just call it a mean since I don't know what the symbol is. It's going to be 25, that's n times 60, which is mu sub x. And our standard deviation is going to be the square root of 25 times, instead of being divided by square root of 25, multiplying by square root of 25. So 25 times 60 is 1500, and this is 5 times 9, which is going to be 45. So we have our new mean and our new standard deviation. So their distribution will be described with a normal distribution, a mean of 1500, and a standard deviation of 45. Part H is finding the minimum value for the upper quartile for the sum. So if we imagine the sum of distribution looking like this, another bell-shaped curve because it's normally distributed, except now our mean is at 1500. They want to know the upper quartile, so the quartile is 25%, and they want to know what the lowest value for the upper quartile is, which means we have 75% on the left. So this is going to be an inverse norm problem. Inverse norm, and then we have a 75% and a mean of, remember our mean is not 60 anymore, it's 1500 for the sum, and our standard deviation is 45. So let's take a look at that. This will require us to go back to an inverse norm from the second function in vars, 75%, and then our mean of 1500 times, or not times, but comma, the standard deviation of 45. and we got a 1530, so that's over 1500. It makes sense, it's on the right side, so this value is 1530. And that's the amount that's going to be the lower or the minimum value for the upper quartile. And then finally, a probability question. So they're essentially looking for the area from 1400 to 1550. So somewhere over here is the area that they're looking for. And this is going to require a normal distribution, normal CDF command. They have the low and the high, and then we just provide the mean and the standard deviation. And so whatever this will turn out to be will be our final answer. So it's a normal CDF. We got 1400, 1550, 1500 for the mean, and 45 for the standard deviation. And so that's going to be about 85%. So that's 0.8536. Okay, it looks like it's a coincidence that it's 0.8536, but if you look at the number of standard deviations away from the mean for both of these, for E and for I, it'll be the same thing. Okay, so this completes problem number 1.